Okay, Coroneos 100 integrals, number 59. Okay, so this time we need to integrate x over 1 plus x to the power 3 here. Now this is a pretty hard question. Because if you think about it, the derivative of the denominator, we've got 3x squared, but we only have x on the top, so we can't really use the reverse channel. So, like, for just to start with the question, you can't use the reverse channel. This 1 plus x to the power 3 looks like it's the sum of two cubes. So the first step what we need to do is to factorize the denominator. So hopefully we're going to use the partial fraction to do this question. All right, so that gives us 1 plus x and 1 minus x plus x to the power of 2. That's how you factorize the denominator. So once you get to this point here, then we can say let a over 1 plus x plus, for the next one, because the denominator is 1 minus x plus x squared, so it's the highest power is power of 2, so therefore for the top it has to be a linear function, which is bx plus c, and that is equal to, okay, the questions we have. All right, now our job is to find out what is the value of a and b and c. So a bracket 1 minus x plus x squared plus 1 plus x multiplied by bx plus c, and that gives you x. All right, so we're going to do some suitable substitution to find out the results we have. All right, so we're going to let x equals to, let's just try -1 first. Because once you substitute -1 inside there, all of those cancels out. At least I'll get the a values. So a bracket 1 plus 1 plus 1, and that gives you -1. All right, so that gives you a equals to -1 over 3 here. Okay, next we're going to let x equals to 0. If we let x equal to 0, it seems so we have already got the result for a. If I let x equal to 0, so b cancels out, at least I can get the value of c. All right, so that gives you a plus, if we let x equal to 0, just a plus c is equal to 0. Now we know what a equals to. A is equal to -1/3, so c is equal to +1/3. All right, so that's easy. All right, so the next one is we let x equals to, well, I guess for this time, you don't really have any other options, so we'll just pick a number that's easier enough, maybe just 1. All right, so that gives you a, and if we put a 1 inside, it does give us 1 minus 1 plus 1, which in the end is just equal to 1. Plus, now that gives you 2, and b plus c is equal to 1. All right, so we're going to substitute the numbers back inside. We know a is equal to -1/3, and we don't know what b equals to, but we know c is equal to 2 over, or c is 1/3, but you times by 2, that gives you 2 over 3, and that's equals to 1. All right, so if we do some simplification, 2b plus 1 over 3 is equal to 1, 2b is equal to 2 over 3, so b is 1/3 again. All right, so it does take a while just to find the value of a and b and c. Take a while to do it. All right, now let's just let's replace this one by the fractions we have. All right, so a is -1 over 3 over 1 plus x. For the b and the c, they're both equal to 1/3. So in this case, probably it's better just for me to take 1/3 outside. Okay, it's just easier. I probably can just take a 1 over 3, put it back inside in front of, as well. All right, so bracket, and that should give you x plus 1 over 1 minus x plus x squared dx. All right, okay. So I'm just going to drag this one to the sides. Okay, so we've got more space to do the question. All right, now for this one is actually quite easy. It's just log. All right, but the problem here is now how do we integrate that term on the right hand side? Okay, or the second term here. All right, so the next step you do is we need to use algebra manipulation. The derivative of the denominator is just 2x minus 1. So we kind of need to change the numerator into 2x minus 1 as well. So for this question, I decided that, it's better for us to maybe separate into two parts to do it. Okay, just a bit easier. So we don't have to do all the things together in one line. We can break it up into two parts. All right. Okay, so let's start the process now. All right, so that for the first one, it's just -1/3 ln absolute value x plus 1. Now, for the second one, what I need is the derivative of the denominator is 2x minus 1. So I want to get 2x minus 1. That means if I just put a 2 here, I need to times by 1/2 outside. So times by 1/2, that gives you 2x plus 2. Okay. However, remember we need 2x minus 1. So I don't want to change. I want to change this plus 2 into minus 1, but plus 3 on the top. Okay. So in this case here, it's just like, plus 2. All right. Dx. So that's -1/3 ln absolute value x plus 1 plus 1/6. Okay. 1/6. Integrate, so 2x minus 1. So now we can break this into two parts, plus 3 over. Okay, for this one, unfortunately, you have to, later you have to do completing a square again. It looks like that's a tangent inverse integration at the end. Okay, so again, we'll just keep doing it. 1/6. I think I can just break this one up into two parts again, but I guess it's a bit easier if we just continue to do the question like this. All right, so we need to divide this number by 1, so by 2, which is half, and square it. So that gives you 1/4 minus 1/4 plus 1 dx. It's a pretty long process here. Okay, all right, that does look like a 3, okay, yep, that's better. All right, so that's plus 3 over x minus half square plus 3 over 4 and dx. All right, so now once you change into this format here, definitely you can see that is a tangent inverse, all right, after you integrate it. Alright, so just keep copying this. You don't have to, copy this one done. You can actually start with the integration if you want to, so you can actually find out the answers. I just prefer to do it like in one line. Alright, so what I need to do here is think about this one. That's a 3 on 4, but I do need to change this one into like an a square. So how about if we just do square root of 3 and a 2 and like every single raised to the power of 2. So that's a bit easier. All right, that's a bit easier. Okay, now, once I've done that, I should be able to integrate, okay? But let's just do it at the end as a final step. Oh, that's a long question. All right, so let's now finally integrate what we have. All right, put up large brackets. All right, the derivative denominator is numerator, so that gives you ln absolute value x squared minus x plus 1. For this one here, I'm just going to take the 3 outside first, okay, and then this is inverse tangent. So what we need to do is we need to find the reciprocal of that one because that's supposed to be 1 over a, so it'll be just like 2 over square root of 3. And then what we need to do is tangent inverse, copy everything down inside this bracket, and divide it by root 3 over 2, which is obviously the reciprocal. And it's better if we can write in terms of reciprocal, but that's okay. We have another line to tidy up our expression here. So the final answer is this one here, plus, now we times 1/6 inside. Oh, okay, ln absolute value x squared minus x plus 1. All right, now remember we need to times 1/6 back into here, so that gives you 1/2. And then once we have 1/2, they cancel with the 2 up there. So you just have to be very careful with the algebra behind. So that's 1/√3 tangent inverse Now let's move the 2 over on the top. That gives you 2x minus 1 over square root of 3 plus c. And that becomes the final answer to this question. As you can see, it's a really time consuming question here. First of all, you need to know that you're going to use the difference or the sum of 2 cubes to change it, all right, and to factorize into 2 factors. Then you're going to use the partial fraction to do the question here. Find out the result for A, B, and C. Once you get to this point, you also need to realize that I have to use the algebra manipulation to change into 2 more fractions, and then you have to use completing the square for the denominator and realize this is a tangent inverse. So lots of skills here for one question. What I can see is, factorization, partial fraction, algebra manipulation, reverse chain rule, completing the square, and obviously realizing this is tangent inverse. So it's a pretty crazy question. Okay, all right, thanks for watching.